All right, now, hello again. Our second question for today is going to be x to the fourth minus 11x to the third plus 41x to the second minus 61x plus 30. So this one's a bit annoying because it requires a bit more work. So we've been given a little bit of help here. We know that x to the second minus 4x plus 3 is a factor. So what this allows us to do is long divide. We take our original function here, x to the fourth, and we divide it by that factor. Because we know if this divided by this, well, okay, so we know that because this is a factor, this times something else will equal to this. So this divided by that will equal that something else, which we need to fully factor. So first thing we're going to do, as per long division, we're going to find what we have to multiply this by to get it to equal this, so that when we subtract these two, it will equal 0. In this case, it's x to the second. We take the x to the second, we multiply it by the two other numbers here, and we'll get these, negative 4x to the third plus 3x to the second, and then we can drop down the negative 61. So when you subtract these, you'll get negative 7x to the third plus 38x to the second, and then when you drop down the negative 61, you'll get negative 61x. And then we're going to do this whole process again. So what times that will equal negative 7x? 7x, nice and easy. So negative 7x plus 7x to the third, you'll get 0. Oh, excuse me, it's minus. You're subtracting these two. Negative and negative will be positive. Negative 7x, you'll get 0. Plus 38x to the second, so you're subtracting these again, so you get 10x to the second. 61 minus, plus essentially 21, you'll get negative 40x. And then we do it again, or final time. Hopefully we get a 0 at the end, otherwise we'll have a remainder, which means these are not factors. So 10 into x to the second, that will give us 10x to the second, lovely, minus 10 times negative 4x, negative 40, lovely, 10 times 3, 30, lovely. Subtract these two, and we get 0. So we know these are factors. So in the end, we know that x to the second minus 7x plus 10 is equal to x to the second minus, we know that x to the second minus 7x plus 10 times x to the second minus 4x plus 3 will equal x to the fourth minus 11x to the third plus 41x to the second minus 61x plus 30. So the next thing we want to do is make sure that that is the fully factored form. And so we're going to do that by looking over our equation, our new factored form, and seeing where we can simplify. So in this case, I spotted that if you multiply negative 1 and negative 3, you'll get 3, and it'll add up to negative 4. So we know that we can simplify it down to x minus 1 times x minus 3. On the other side, we can do something very similar. We know that negative 2 times negative 5 will equal 10 and add to negative 7. So x minus 2 times x minus 5. We can all put this in a lovely, dovely equation, and that also gives us our zeros. So now we know that our zeros are, mind you, keep in mind that these signs are flipped, so we're actually saying that our zeros are the opposite of these numbers here. So our zeros are 1, 2, 3, and 5, which makes our x-intercepts 1, 0, 2, 0, 3, 0, and 5, 0. And here, we can go back to our original equation to find the y-intercept, which in this case is 30, because it's always going to be the whole number in the original equation. So because this is a polynomial equation, we know that our domain is going to be infinity to infinity, or all real numbers. We know that our range we actually don't know our range. We can't tell our range because so this graph is going to look something like, it's going to come down, up a little bit, down a little bit, crossing the x-axis, up again. To find the range, we'd have to multiply, we'd have to put in the x value for every single x value between the x-intercepts, which is unfeasible. It'd be very difficult to do, annoying. So we're not going to do that. The range is effectively, we don't have enough information to effectively find the range. So this is what we're going to get here.